Hello everyone. In this video, I will present the content of Mathematical Logic course. This course is intended for first-year students in the Common Core of Computer Engineering, and it designed to give you a strong foundation in formal reasoning, which is essential in both mathematics and computer science. So, let's take a look at the general presentation of the course. This course introduces you to the fundamental tools of formal logic with strong emphasis on how we use them in mathematics. You will explore both propositional logic and predicate logic and learn how to formalize statements and how to evaluate their truth. This course is progressive and builds step by step on your understanding. Now let's look at the main objectives of this course. First, you will understand the fundamental of logic, including its definition and applications. Second, you will learn to identify and apply the main logical operators and quantifiers and understand their properties. Third, we will explore implication and equivalence and how to reason correctly using them. Then you will be able to build and evaluate logical models using truth tables and formalization. Another important goal is to use logical principles to build valid and well-structured mathematical proofs. And finally, you will learn how to organize your reasoning and express logical arguments clearly and coherently. Let's now move on to the prerequisites, what you need to know before starting this course. First, basic set theory like union and intersection. Second, functions and relations, since they are essential in predicate logic. And third, you should be comfortable with basic logical symbols as well as quantifiers and what they mean. Let's move on to the course content. The course is divided into three main chapters. Chapter 1 is an introduction to mathematical logic. Chapter 2, a detailed study of propositional logic. And Chapter 3, titled Predicate Logic, which is more powerful and closer to how we write mathematics. Now, let's begin with Chapter 1, Introduction to Mathematical Logic, which will take us about 2 weeks. First, we will start with a fundamental question, what is logic? In this section, we will explore the meaning of logic from both general and formal perspective. Then, we will look at different definitions of logic. After that, where and how logic is used. You will see its applications in real fields, especially in computer science. In this section, we introduce basic notions of any formal logic system, such as language, syntax, and semantics. Finally, we will introduce classical logic. It mainly includes two branches, propositional logic and predicate logic, and both will be the central focus of this course. We move on to Chapter 2, titled Propositional Logic, which we'll study over 6 weeks. We begin with an introduction to propositional logic, where we present the basic concepts that form the foundation for the rest of the chapter. Next, we study the language of propositional logic, including the basic symbols, logical connectives, and how to form well-structured propositions. These sections covers how to convert logical formulas into conjunctive normal form CNF and disjunctive normal form DNF. These normal forms are essential for simplifying formulas. In this part, we explore the principles of logical reasoning and how to determine whether an argument is valid or not. Finally, we introduce propositional resolution, a method used to automatically prove logical formulas. Now we arrive at chapter 3, titled Predicate Logic, which is more expressive than propositional logic. First, we examine the limitations of propositional logic and why a more expressive system, predicate logic, is needed. Then we introduce the formal language of predicate logic. Here we study substitution, how we replace variables with constants or other variables in logical formulas. Next, we learn how to translate natural language statements into formal logic expressions using predicate logic. In this section, we explore two important forms, prenex and scholen form, that simplify logical formulas and make them easier to work with in formal reasoning. Finally, we learn proof by refutation, a method that assumes the opposite what you want to prove and finds contradiction. Now, let's take a look at the concept map of the module. It gives you a global overview of the mathematical logic course and summarizes the structure of the module. So, this map will help you understand how everything is connected throughout the semester. You can always come back to it as a reference while we progress in the course. For those who want to go deeper, here are some excellent references. This concludes our presentation of the mathematical logic course. I hope this overview gave you a clear idea of the course, structure, content, and what to expect. Thank you for your attention. Your teacher, Dr. Soraya Farah.